Hello, everyone. My name is David Sampson, and I'm with,
Mathew Sousa.
and we're talking to you today about isolation and securing of IoT devices.
So, our problem statement, people believe device security out of the box is good, but a lot of default credentials on IoT devices are well known and are available on Google. So, an example of a username and password combination is admin and 12345, admin and pass, and admin and 123456.
So we set up our infrastructure around what a standard internet home user would set up. Originally, we were using an IPS system. However, due to limitations with both the Bell Home Hub with fiber as well as limited budget for home infrastructure, we ended up just testing against a Bell Home Hub as a local network router, with a monitor and two Wise V2 cameras. We did enable the security defaults on the Bell Home Hub, which are designed for firewall, basically firewall and packet filtering.
So, some problems we ran into were our IPS wasn't able to be configured properly due to limitations with the Home Hub 3000 when used with a fiber optic cable. Our scope was also altered to reflect a more realistic home internet and small business environment. Our IPS ended up not being relevant to testing as DOS attacks were not used in our testing. So some of the limitations to our work were hardware costs, available infrastructure, physical space limitations, as well as COVID-19 social distancing measures.
So some of the tools we use to test this problem, I'll start off with the attack tools we use. So we use Kali Linux as our main operating system for the attack machine, and use three standard tools with it. These are tools that come with the machine. That's Wifite, Nmap, and aircrack-ng. We used Wifite primarily for the WPA attack, aircrack to decode the packets, and Nmap for network scanning. VLC was used to view the RTSP stream. Windows 10 Desktop was used as the monitoring machine for the camera, so it was what was physically viewing the feed, effectively like a security room. Bell Hub 3000 was my home modem, as it is connected to my fiber optic, and I don't know how to change it from that. The Snort Security Onion was supposed to be our IPS system. However, due to issues we had with the managed switch and with the fiber optic, we were unable to get it properly working. The Wise application was used for the cameras to program them with the RTSP and then to make sure that access to Wise servers had been shut off, and Android screen recording. So setting up the network, we set up the network much like the diagram suggested, minus the IPS. We installed the RTSP firmware on the cameras and generated the RTSP using the default settings. So the RTSP firmware was provided by Wise. They allow you to have your camera set up as general IP cameras using the real-time streaming protocol. We then blocked the cameras using an access control list on the router. This prevented them from communicating with the Wise servers. However, it still allowed them to communicate over the local network. This was part of our isolation protocol for the camera. We then enabled firewall settings on the router using standard settings. We then connected the monitoring machine, which was the Windows 10 machine, using Wi-Fi to the R&D SAMS network, and used VLC to view the two camera streams. So you can see there was 192.168.2.49 and .48. Those are the two Wise cameras. We differentiated them because one has the Wise logo at the bottom and the other one does not. We then commenced the attack. So this is using the Kali machine. This was using Kali bootable key. To simulate a weak password, the network password was temporarily added to the word list. This is my home network, and I didn't want to change my home network to a weak password. We used the rocku.txt list. So as you can see here, we began our Wifite attack. This required monitor mode being enabled on my WLAN 0 interface, which we used AirMon to do. As you can see, R&D SAMS is at the bottom. I'm not sure why the signal strength was showing very low. It was right next to the router, so that's probably just a signal issue. The attack commenced using a deauth attempt. So what it does is it sends deauth packets and captures the handshake. So we were able to capture the handshake and then used aircrack-ng in combination with that modified Rocku text pack in order to properly break into the packet and decode the hash. We were able to find the key quite quickly as we put the password right at the top of the list, showing that if the user was using a default or an insecure password for their wireless connection, they'd be vulnerable to this attack. This attack took 10 seconds to launch and properly gain access to the network. Right, once connected to the network, we use Nmap, which is our network mapper, to scan the entire network. That's 192.168.2.0 with the subnet mask of 24. This shows all of the available devices, all the available clients on the network, and we found the cameras quite quickly. They were very easily to identify because they are the only ones using that real-time streaming protocol port, which is 554. Using some very quick OSINT involved just Googling it. We were able to figure out what the general URL structure was. So we Googled sample RTSP streaming video URL, and the second result gave us the exact URL that we needed, including the username and password combination. Right? We used a variety of different username and passwords, admin pass, admin12345, admin123456 throughout, and all of these were available doing some quick Google searches. The /live we were able to figure out using the fact that the most common IoT camera that has RTSP enabled is Wise, and Wise gives you this general link structure on their website. Once in, as Adrian Fermento says, bing, bang, boom, I'm inside your living quarters. We were able to open up VLC using snapd in Kali Linux and view the camera feed, thereby compromising the confidentiality of the cameras. So testing results, rocku.txt password list contains the world's most common passwords. 86% of users still use default passwords. 86% of users still use bad passwords. All of these users would be compromised by this rocku.txt password list. You could use a laptop, you could use a desktop. If you were really using a more ingenious strategy, you could use a combination of password lists, right? There's so much breach data available. By changing the password from the default, a WPA attack will never really work if the password's not on the word list, right? WPA and WPA2 are very, very secure. And so unless you have a compromised password already, you wouldn't be able to get in. There's just too much entropy. Similarly, a link cannot be recreated using OSINT for an RTSP camera if the username and password change from default IDs. Again, there is just too many different combinations, even if you're limited to 4 to 10 different characters, right? If you changed it from admin to, say, user even, or if you change it to a specific username and a specific password, you would never be able to recreate that OSINT link. So the solution, changing passwords. Add complexity, add length. This will increase the entropy value of the password, increase the security of the devices by far more than any other security measure. It's also the cheapest, right? You don't have to spend thousands of dollars on an IPS. You don't have to spend thousands of dollars on a host-based network scanner. You just need to change the passwords, right? And again, research shows, after analyzing 15 billion passwords, the most common password is still password, right? This was in 2021. Nothing really has changed in password security over the last 30 years. And so regular users, home users, small business users will still keep these default passwords. So in our attacks against the Wi-Fi network now, we removed the password from the word list and use a different word list. This allows us to begin the attack using Wi-Fi again. As you can see, we running aircrack against it using wordless probable.txt, which is another similar word list. It was still unable to break in and get the key. We tested 22,000 keys per second, and we were unable to find it. Now, what if they social engineer the password? Okay, so they've got it into the Wi-Fi network, and now they're trying to connect to the cameras. Now, sure, they can re-engineer the RTSP link structure using OSINT, but they can't get in now, because if they try to use any of the default credentials, they'll be faced with this RTSP authentication screen. And each one of these is a request to the camera that a SIEM or an IPS would see and be able to flag, and then if you have a host-based scanner, you'll be able to ban that device immediately. So as you can see here, upon a failed entry, the attacker will see this RTSP prompt, right? And the RTSP prompt is great in that it doesn't tell you if the password is invalid, doesn't tell you if the username is invalid. It just says, it doesn't change the screen until you get it right. So it'll say, please enter a valid login name and password. So you can put in admin, which is a right username, and the wrong password, and nothing will change. It'll still say both credentials are either invalid or not valid. So with one simple fix, we're 100% more secure against scripting attacks, right? So this is against a simplistic attacker. An obviously more complex attacker would be able to potentially get in using like either vulnerabilities or sniffing the exact RTSP packets on the network if they were able to compromise the router password. All of these things, though, can be easily prevented because complex attackers don't typically attack home networks. They don't typically attack small businesses. They're after cash.
So here we've identified some more areas for future study. So the first one is SIEMs, which are security incident and event management logs. These are used to collect logs on all the systems on the network. We also have stateful firewalls, AI managed systems, host scanning to detect hostile devices, and IPS non-default configurations as well.
So, in conclusion, use good passwords, right? One of the biggest things that we can do as cybersecurity professionals is encourage password strength. There are two main avenues that people get in: social engineering and password security, right? If you reuse a password, if one password is compromised, then your whole, and you're using that password everywhere, every system you use that password on is also compromised. Even if the attack face surface isn't that high, right, it is still possible to get into. You can deploy an IPS, you can deploy malware scanners, you can deploy all of these things, but if someone just knows your password, then all of those security measures are bypassed. So the biggest takeaway from our research and the biggest takeaway from the testing that we did is by changing from the default passwords, you are able to exponentially increase your device security. And that wraps it up. Thank you very much for listening to our presentation. We'll be going to our live. So the first thing that we're going to do is add the cameras to Wise and set up the password using RTSP. Now, all of the RTSP settings we're going to leave as default for now. So what you're going to see here is us connecting the Wise cameras to the Wise application before we ban them using the access control list. As you can see here, the is recorded from my Android device. So bear in mind any quality issues on the sizing and all of that. So this process here is one of the most annoying parts, is you have to scan a QR code using the camera itself. That's why it's paused on here for a little bit. And then once this completes, you'll see the little checkbox I heard QR code scan get clicked, and that will show that it did record it properly. And then the camera will connect, and then this time actually the camera struggled to connect, and there was able to get it to connect initially, but this shows the connecting process. And the camera, as you can see, was successfully added. The password of 123456.
So here you can see we have a Bell Home Hub 3000, which is the modem we're using. Right here we have both Wise cameras, 1 and 2, which are connected to the primary Wi-Fi. So we're essentially going into each camera and changing the access control, which is set to always allow access to the internet. And we're changing that to block access to the internet always. So we're just saving that for the second camera here, and once that's done, both cameras will have access to the internet blocked, which is what we wanted.
So this next thing that we're going to show is how to connect to the camera using VLC. So this is from the monitoring machine, also known as my desktop. This uses VLC's network streamability, and RTSP is real-time streaming protocol. Now, Wise uses a very standard link format of RTSP : / username, password, and then IP address /live. This can be gained from the Wise website, and because Wise is one of the most popular RTSP cameras, it's very easy to reverse engineer this link, as you will see later on in the demonstration. This here is the camera feed. It is pointed at my window because I do not like having smart cameras pointed inside my home. You will see, though, that this is a live feed. As you can see, there's a little timestamp in the bottom right, and I will flip this camera around and point it at my face shortly. Yep, and there I am, looking very confused, but there's how you connect to the Wise camera. The next thing that we're going to look at is how to launch the network attack. This is using a Kali Live boot key. I apologize for the camera quality. I had to prop my phone into a tissue box and then type in the commands because Wifite requires actual interaction. So what I'm doing right now is I'm typing in the word Wifite, and that just activates the application. It will automatically turn on and enable monitor mode on the network interface. Now I have I believe just a regular Wi-Fi card in this laptop, but it allows you to enter promiscuous mode, which not many wireless cards do. This allows you to basically scan and detect any networks around you, as well as intercept packets from them, and basically turns on and be like, hey, I'm an access point as well, and give me your information. So right now what's happening is I'm looking through the list to look for RNDSAMS, which is the name of my network. I actually did see it earlier, but it takes me a little bit to notice it because it's right up at the top. It should be, I believe, number 3 if memory serves. And then what I do is I type in the number 3. Yep, you can actually see it. I just scrolled past it. You type in the number 3, and then it begins the attack. Yep, they're pointing it out there. RNDSAMS at the top. hit enter, and then it'll begin a deauth attack against it. Now, a deauth attack will basically send a deauth signal to a client that's directly on the network and will attempt to recapture the handshake that it sends back to the router. Now, this allows us to basically gain the handshake between the three-way handshake, right? And what we can do is once we have that handshake, we can attempt to decrypt it using aircrack. So as you can see, we captured the handshake here, and it immediately tries to use its own word list to do it, but we're going to use the RockU test, so I terminate this process here. Now the next thing we do is we use aircrack ng with the RockU text password. It's very fast because I put the password right at the top, type in the command, spits out the password. So now that we have the password from aircrack, right, because we were able to find the password inside the word list, which we had added to simulate a weak password because, you know, I don't want to change my password to a weak password because I don't want my home network to be unsecure. We're able to connect directly to the network using the wireless adapter, right? So we have disabled promiscuous mode. We've put it back in normal mode, and that allows us to connect to the Wi-Fi network directly, which would bypass any intrusion prevention system because we already have the password. The next stage is to use Nmap-F to map the network. We use the subnet of 24 because it's a very standard home network subnet. As you can see here, the command returns very, very quickly. Now you can only see one camera on here. We were having some issues with camera 2 at the time of this recording, but it does show the port as well as the IP address, which is pretty much all the information we need with default credentials to get into these cameras. The next thing that we did is we used basically Google to find a link, right? So I'm a big fan of OSINT. I'm a big fan of doing research to get into things. Now you can see here, right, we just put an RTSP link format and we've already got the majority of the information. We know how the RTSP link is structured, right? We've got the basic username, we got a basic password, we've got where the IP address goes, and we've got the end of it. Now, we had to do a little bit more than was shown in here to really showcase it, but in order to keep with a 20-minute timeline, we are able to look at the wise.com website itself, which gives you the RTSP link structure. So we know that the end of the link is /live. We know that you don't need to put the port number for a Wise camera. You just need the IP address because all other ports are already closed. So there's only one valid port. And you just need to put in the username and you need to put in the password and you're in. Now we used 1, 2, 3, 4, 5, 6 as we had shown earlier, which you can also find using more OSINT, right, as it is a default password as well. There are also ones we set up with pass. We set up one with a secure password as well, as you can see later on in the demo. And as you can see here, we're able to type in it. So all of these things we found by just Googling, right? It took about 5 minutes, and you'll see that the camera has been compromised because we're able to connect to it and view a live feed from it directly. The next thing we did is we started securing the devices by changing the RTSP password. Now this was done through the Wise application. As you can see here, there's a generate URL screen. So now it unfortunately limits you to 10 characters. So what I did is I added some capitals, I added some randomness, and basically changed it from the default. So now we have a new link, which is pretty much impossible to reverse engineer. You can get the end part, you can get the beginning part, sure, but you can't get the username and you can't get the password. The final step we took to secure using the defaults is changing the password of the wireless network. Now this was done by removing the password from the word list, and that allowed us to simulate a password change to a secure password because this password does not exist on the RockU test. Now we tested this for up to 10% of the RockU test list. However, knowing that the password is not on the list, this would still be impossible had we let it run for all 1.4 billion keys. This is a very realistic test case, as most users, if an attacker was scanning a home network or was scanning a small business network and they weren't able to get through this, they would not realistically bother trying to go further, just because what would you gain out of it? Like, sure, you can gain and get the confidentiality of the camera, you can see what the camera is looking at, but unless there's something valuable on there, is it worth the time, is it worth the effort? And for the majority of users, it's not, right? For the majority of users, these are all of the security controls you need, right? So this would help about 86% of the population, right? Based on our research, those are the users that are using these devices on their home networks with the default settings, right? Most people who buy these out of the box don't bother to set up extra security features. They don't bother to turn on the firewalls. Don't even bother to change their home internet after the bell guy comes, right? And that's something that we are aiming to show with this report. And last but not least, we are looking at reverse engineering the link. Now, as we pointed out, because we've changed the username and password, they'll be unable to get in, but what will the attacker actually see? Okay, so will they just be faced with the same screen? What will happen? So we said use the admin pass credentials, and you're prompted with this login screen. Now, the beauty of this login screen is it doesn't tell you what you're getting wrong. It doesn't tell you if the username doesn't exist. It doesn't tell you if the password doesn't exist. It just doesn't let you in, right? And this is what the attacker would see. They try and use their default credentials, and eventually, if you were to try scripting something like this, you would get flagged by SIEM, you get flagged by a host-based discovery system, you get flagged by any other security feature, and thus we have effectively secured the IoT device as well as isolated it from the WISE network without compromising the availability to an authorized user.